the motors are all working. So let's dive into it. All right, so we're using PWM. That's fine. I just need to edit you. Okay, so we have this file here. Do you want to just run it and see this is up?
Yep.
LED pin 12 is what we called it currently. There we go. Thank you. Okay, and let's just see it all work. Is the camera going to be able to see the motors? Maybe just move it a little bit down, actually. Yeah. And it's elevated, so it's not going to drive away on us. All right. Moment of truth. And we're going to try on the first one. Python 3, loader PWM. Oh my god, it worked first try. Up and down. Okay. I actually don't know how many times it goes up and down. Oh, it's a while loop. It doesn't indefinitely.
Yeah, indefinitely.
Okay. All right, great. What other motors do we have? Okay. Can I kill all these swaps? So interesting.
All these what? Are you there, Nacho Kitty? Did you witness the wheel turning? Woo! He is right. Yes.
1 sec. Sorry. There's every time we lose it trying to we disconnect from the internet because we accidentally unplugged it when I'm connected. It's been creating these like save files, and I don't really want them. Okay, so that was on LED pin 12. Do we want to try any of the other motors, or do we want to maybe cycle through the motors? What would you like to try next?
Didn't watch you guys miss Beatus. Wait, what? Beatus was here? What?
Is Beatus back?
Beatus, are you there?
Okay. Well, that happens. Let's go and create some code. So what other pins do we have? Motor pins.
Yeah, give me another PWM pin.
Or you want to just try? Okay, cool. I need to reopen my stuff.
So what I want to do right now is find out which motor this one is. Which what I want to do now is keep that one there where it's at, and find out which pins on the motor driver correspond to this motor, so that we can tie them together.
Okay.
So I'm gonna get you to find me another PWM.
PWM, here I come.
So I'm assuming it's these ones. Actually, you know what? I know which ones it is. I'm gonna make this work. I'm gonna just make it work. You ready?
I'm ready for motion.
Okay. I'm gonna use a female to male and then a female to male again. What's going on, Beatus? How you been, buddy? He's still here. Oh, I thought that was Nacho that said that.
Okay, so you want another PWM?
So, no, I know.
You have
I'm gonna
already?
get you to do this. I'm going to test this hardware from a hardware perspective.
Oh, okay. Well, let me give you the full thing.
Let me put that there. You're not going to do anything for good.
I like it. Did you unplug it yet?
Five?
Yeah. No, actually, I'm so good.
So do you wanna come see what I'm trying to accomplish?
Yeah.
So I'm basically trying to use this as a jumping position. So this is gonna connect here. And this is gonna connect here. This is where it gets a little bit messier. It has to, because that's what it is. And we need two more male and females. You said anything wrong? I haven't been talking. That's for sure.
Here, work the first try. This is much better than school went. Nice work.
Yeah.
Excellent. Thanks all for joining us. Great. And we're kidding. That's a long cable.
Yeah. Yeah, it's getting a little messy right now. We'll have to find a better way to jump these. Maybe I will splice the next time. That must be down with each ready.
I don't know what exploded. Okay, so that is going to both of these.
So that's going. So, what do we have here? So this is ground. So this, and this are the same cable.
Yeah, just pair them up. These guys.
Yeah. So that means, so this one's going here. This one's going here. So that means this one's going to go to the outside. Right. That means that's equivalent. And then this one goes to the inside. That means this one goes to the inside. Wait, what? Oh, this one goes to the. So this one goes to the inside. This one goes to the inside. And one of these. So then one of these goes to ground. And ground is. So 1, 2, 4, 6, 8,
Right. Ooh.
10, 12. Not bad. But actually,
That's 14. Isn't ground 14? Because 12.
6.
Did we just press it?
Yeah.
I'm smelling something different now. You smell that? Unless it's just the motors warming up. Maybe it's just like dust coming out of the motors.
Sure.
All I know is it smells different. And I'm just cautious.
Some does smell.
Alright, so it's not just me, right?
I don't think so.
Okay, well.
2, 4, 6, 8, 10, 12, 14. Let's go there. That goes to the same as that. Those are tied together to the front. Those are tied together to the back. Alright, give her help. See what happens.
Okay, so I'm giving 12. Power 12.
Power 12. So
Two of them. Are they opposite?
They're opposite.
So I want them in the same.
They're getting different. Yeah, I'll fix that here.
That's cool though. That sort of concept right there.
So this should make them go the same.
Ready to go?
Not yet. Go ahead.
Beautiful.
Perfect.
Alright, same deal for the other ones?
So we have these two working parallel. And that's what we want.
Yeah.
And do you think that was forward or reverse, or do you know? Do you care? Well, I guess
I don't care.
so. These are the control pins for that one. Okay. Oof, this is chaos. Alright.
Because I think it's about is a sign that's offset. So we'll just pitch
Whatever.
is forward is
Yeah, we define that. Fair enough. Good point. So let's say, since these two control pins are dark, let's do these two control pins are light. Let's do a yellow and another yellow.
I just want to be consistent with like ground and power.
Yeah, that's fine. Control pins can be fucky. It's fine.
Oh yeah, control. Yeah, that's okay. Doesn't make it the easiest. We'll label them later.
Yeah, the only ones that matter are these ones, because these are the controls that are apply. Everything else can stay stationary. We should draw this diagram.
This is the front. Okay.
I know.
I just like realized.
Feels like the back.
Yeah, it's okay.
We want the camera up there though.
It's alright. I'm no worries. Just realizing more and more that I got it. Okay. Let's keep going. Sorry, I'm just distracting.
Okay.
So whatever we did there is perfect. So show me so that I can do it, and I'll do like the audience who's learning this.
So what do you want? Sorry.
So okay, so you are connecting. So these are the two pins here. We want to put these two pins connected to this bus.
So we want one of these pins to go to one of the buses, the other pin to go to the other bus.
Cool. And then we'll do the daisy chain. Or like put multiple there. Okay. And you're using yellow for these two. And you usually use this.
Well, I want yellow to be what goes into this. So
find another PWO.
Yes, find another PWO. Please and thank you.
Okay. So we're looking for another PWM port. Let's go to the simple guide here. Do you prefer what side?
No.
PWM. Maybe this is not as useful a picture as I thought it was. Let's go to this one.
If you just give me the number, I can find it.
No, it didn't have it labeled there. 20. Which number is it? Like 32 or 26? What's the end? Is it 40?
40. Yeah.
Okay. It is 32, 33, and 35. 32, 33, 35.
So 32, so I'm at
32.
16, 18, 20, 22, 24, 26, 28, 30, 32.
Yeah.
And that's confirmed by going 34, 36, 38, 40. So 32.
32, PWM 0, GPIO 26.
Okay, so this is 32. Right here. 32 is going in there.
Why does it say PWM 0, PWM 1?
I have no idea.
Like they're not going to give us the same value, will they?
I can't imagine.
Because that means we're going to get 2.
I agree, although there's no way.
Okay.
Okay, so that pin goes in there.
If, let's say we didn't have enough PWM pins, are we able to use others?
Mux. Others?
No, I mean like other pins? The other GPIO pins?
We just won't have speed control.
Speed control, okay.
PWM gives you that variance in voltage.
Right, okay. Right, the 0.5.
Exactly. The 0.5. Okay, so now I need, so I got that one, and that's gonna go, it's gonna go 2 places.
Do you need another ground? What was that? That's ground, right?
So what happens, so you get one from PWM, so I got my PWM, then I need one from ground, yeah. Yeah, so I need,
Do you want a ground pin?
yeah.
There's a ground at 34, so right next to you.
So 32, so 34, there. I'll have to go on this side, unfortunately, because I don't have to leave them. It's gonna get gross. It's gonna work, but it's gonna get gross. We'll have to
It's gonna be
rearrange
good.
some of this wiring, I think. I'll probably do a
Good.
splice instead
Good.
next time. I'll take it apart and splice everything.
Yes, that's correct. Pulse width modulation. Yeah, Nacho Kitty, you know what's up.
Yeah. Yeah, she knows. All right, so that's that. That's that. So now we just need to connect each of those to both of the other ones. So let's do this.
So great, man. Almost there.
Do you want to finish this, or do you want me to keep going?
You're doing great. I'm more of a tanker with my hands. This stuff requires more dexterity. Is usually her department.
This one because it's tight. Thank you. I need all three of these to get in.
Oh my god, really?
Yeah, it was easier on the other ones because I had access to the other side.
What are these? Is this one ground? Could we get ground just another way?
It doesn't matter because it's not going to continue. It's not going to stay ground. It's going to become its own PWM. We're just testing it with ground.
Oh. Yeah. Okay, I get you.
Unfortunately. Let's see if I can.
All right. Well, what is this? This is Velcro down. What if we pick it up and then we connect them all and then we set it back down because it will come directly.
I think I can get it.
I can help or at least.
I'm just cutting off some of our pins. Hopefully we don't need any of those pins. No, that's not gonna work. Okay.
So I was thinking if we lift this up, then you have more freedom to actually do the work, and then we can set it down. We don't have any work.
I might actually just move it down a little lower.
We could probably just leave it. Okay, put it somewhere else.
Yeah. But yeah, I want to put the whole thing a little lower.
Go to see.
There. See what I'm saying?
Yeah.
Just make sure that those stay. Okay.
Can everyone see clearly in the stream what's going on?
This is pretty tight stuff. What do you know about pulse width modulation, Nacho? Pulse width modulation. Very cool.
So it's pretty snazzy. What do you think if we learn how to do 3D printing and print off a shell later?
A shell for all of this, and just put it over top.
Yeah.
Done. And latch it on to all of this.
Now you're talking.
Not too bad. In comparison to the boat that I made and the propeller that I made.
We're gonna finish that boat, man. It's gonna be slick. We'll have multiple boats.
Yeah.
Helps you get numbers that are not binary.
That's correct.
Boom.
That's very simple and.
See, explain it. You can explain it simply. Therefore, you understand it well enough. I like it. I feel like we're now to a point where we say things referencing earlier, and everyone that's new and joining are like, what are they talking about?
Yeah, that's why I feel bad. I was saying that to Nacho actually earlier today, that it's kind of tricky because we'll explain an in-depth topic, and then somebody will join in and they'll be like, "Oh, can you explain that?" Which is fine, of course. I'll explain everything as much as I want, as much as people want.
BDIS coming in with a practical explanation. PWM is how LED lights are dimmed as well.
Yes. Can be. Sometimes. Yes.
A lot of applications.
It's not necessarily how they're dimmed. Well, actually, yeah, probably is. I take back what I was going to say.
That's great. As long as you know how to work
On the internet.
There's only like 1 billion people on the internet, right, to judge it? Uh-oh, so it's not okay. We need some text-to-speech. If anyone can find some text-to-speech software, I'd like to hook it up to Restream. And you guys gonna fight or what? Well, you
The two of us?
You can do the battle cars. Whoever knows PWM the best, build the best car, fight. At least that's how I would do it. I don't know about you.
I'll fight. I'll throw hands.
I'll throw RC cars.
Yeah.
Okay, so everything's connected now. These two should be
This is exciting.
in sync with these two.
So if we run it, it should all just drive in the same. If I give them all the same value, it should all.
Yeah, you have two PWM pins that you have to control now.
Oh god, it broke. Is it still plugged in? Yeah, it's plugged in. It's just me.
So you could just change the pin for now if you want to make sure that the other two work, and then write a quick script to run all four simultaneously.
Yeah, let's do that. All right, everyone. It's coding time. Let me just move this up a little bit. If I can.
Betas said PWM.
There we go. How about that? You want to see everything?
I didn't realize Betas. Betas coming in with the clutch.
With the clutch. All right. Motors time. All right. So I want to change a couple things. Motor 1 pin. Just to make it clear. Motor 1 pin. I'm not going to do any fancy Vim foo right now because I don't recall how.
Foo.
Okay, great. So now let's copy this.
Are you writing the two so that
I'm running both of them. Yeah.
Nice.
Yeah, let's do it. What was it? It was 12 and
32.
32. This is exciting. Oh my gosh, I've been waiting weeks for this. Actually, I could even say I've been waiting my whole life.
What? Aw.
This is sweet. Next up, we're gonna build a Tesla. Sometimes you gotta do some crazy stuff before you can walk. All right, good. I'm just gonna give them the same value right now. Please ignore the inefficiency of this code, but it will work, and that's all I care about. Okay, so what we have done here, we have two variables: motor 1 pin, motor 2 pin, the respective pins that we found in our pinout. We have it set up in GPIO board mode. So that's just meaning that the numbers should be referenced in 12 and 32. As you can see in the pinout, they have different ways of being referenced. They are both set to out. We have a very actually let me just rearrange this.
So theoretically, all four motors, we want them all to run in the same direction. So I'm going to adjust it so that they all go in the same direction. If they don't, I'll change.
Correct.
I'll change the wiring.
Correct. Yeah, that's correct. Then we know what the direction is. Even better if we could say this is forward. Maybe that'd be good. So whatever this value is, which is just positive, negative. Yeah, make sure it starts off going in the forward direction.
So you want this one to come out forward.
Come out forward and then eventually slow down, and then we'll go negative. Because we actually have in the duty cycle here to go reverse.
Oh yeah.
Okay, so we have another one. So we're setting up this.
No, that doesn't really work.
Does this not go reverse?
It just ramps down and ramps up. It doesn't. Reverse.
Oh, sorry. Yeah, you're right. How? Yeah, you're right. Okay.
Yeah.
Yeah.
It's cyclical.
How do we go in reverse though?
Remember, we're grounding one of the pins.
Oh.
We got to put PW.
Oh, there's another pin we have to. Okay. Yeah, I'm a little bit slow today.
We'll get there.
Cool.
There, and we'll do that today. We'll get there.
So yeah, lots to do. Lots of fun stuff. I think we're done. I think we're ready.
Send it.
If anyone has any questions with the code, please let us know. We're gonna rush through it a little bit because we want to catch up. All right, are we ready?
Ready? Hit it.
Boom! Hit and quit it. Are we sure on 32?
Okay, so I'm actually gonna change. Before we suggest. I'm gonna change the direction of both of these. By.
So it did not work, everyone. For anyone to see.
I'm gonna change the direction of these 2 though, so that'll fix that.
Now try it.
All right, ready for this?
That's not gonna change. That's not gonna make all 4 work. That's just gonna change the direction of the first 2. Okay. I just changed the ground thing. Okay. So 32 didn't work.
Correct.
That's PWM.
Correct. But let me. So currently we're set to 12 and 32. So 12 here, 32 here. Now this is a pinout for Raspberry Pi 3A Plus. You said the pinout's the same?
Yeah.
Okay. Are you sure?
1, 2, 3, 4. Yeah, I'm sure.
You can look it up if you want. I mean,
I will. And it is calling both. So that looks fine to me. Has the other pin, has the start at 0. Yeah, I don't see an obvious error there. What version is this? 2 something?
2B.
Two one will be.
See what you're looking at.
Yeah, pretty much. Okay.
32 is, and ground is 34.
So that's the same. Anything that's not making contact, maybe? All right, well, maybe. Okay, well, let's just go back to the basics. Let's just straight up change pin 1. And we don't need to do anything fancy. We know 12 works. Let's make it 32. Make this one 12. All right, running it. Ready?
Yep.
That works? For only one of them?
Yeah, was
Same
that
one.
the same one? Do you want to switch them again and see if it's still the same ones?
Yeah.
Because I don't remember.
I'm pretty sure it was, but I'll do it anyway.
I'm pretty
Okay,
sure it
so
was.
that guarantees it's a hardware thing. I wonder if is it. Okay.
So it's a hardware thing.
All right. What wires do we have, and what do we do differently?
Okay, so we have, sorry.
Actually, let me make it bigger. Yeah.
Oh, I'm done. I see what I've
You
done.
got it?
I see what I've done wrong. Yeah. I took 2 powers to one and 2 grounds to the other instead of 1 of each.
Oh.
That was dumb. Happens to the best of us. Yeah, because like see how this one comes
Yeah,
from the
yeah.
Pi.
Makes sense.
Jumpers here.
Create its own little.
Here it comes to you. I'll show you why I did that. I was all happy. I was like, oh, I don't even have to split the wires. I'll keep them all nice and tidy.
Oh. Now you gotta break it.
So I just gotta take one of these.
So much for being nice and tidy.
Put it there.
You can do a Streamlabs in a way, and I think you will regret it. Oh, is that the fighting in Streamlabs? What was that referring to? I think the timestamp was around the fight. Nacho Kitty was saying that you should fight on Streamlabs. You could
Fight on
you could stream the whole thing. At least that's what I understand. Is that correct, Nacho Kitty?
Alright. Okay, give it hell.
Give her?
Give her hell. That's my bad. I'm sorry about that.
Nope. Text to voice chat. Oh, I was way off. Yeah, text to voice chat. I think so. I think that I like to look at that next time. Motor 3. Boom. Ready. Go. Oh my god! Ah, that was awesome.
Okay, do it again. I'll support it a little better.
Are they all in the same direction? It looks like it.
Yep. You should.
And they're all forward?
All forward. Yeah.
Oh my god.
Okay, so we have total control.
That was a lot. Yeah. Torquey, like I said.
Torquey.
Torquey.
So hardware-wise, we have a functional vehicle.
That is sweet. Oh man. Let me loose. Let me loose.
Look at this.
Yeah.
That's
Beautiful.
beautiful. That's clean. The wiring's a little messy, but I can work with that.
Yeah, and I can live with that. You're great, man. This was awesome. All right. Well, let's get it so we can pick an angle and get these guys working independently. So we have to get direction now.
So now we gotta change. You gotta find me 2 more PWM pins.
Gotcha. Do a flip. Yeah, that's V2. 2 more. We have 33 and 35.
Okay,
So that's 33 is opposite the ground pin that you have,
so 33 is opposite the ground.
and 35 is right after it. 35 is right after it.
35. And my ground right now is 14 and 34. My ground is
Yes,
14.
that's correct. Yeah. So you want across from 34 is your PWM.
And then 35 is the other. So you said PWM is 35 and
33.
33 and 35. Okay, there. That should work. Okay, so what you need to do now. So now we can set those PWMs to 0, but if you want to change direction, you have to energize the other PWMs, 33 or 35.
I'm so excited right now.
So we need to, here, I'll help you with this. So right now, I'll draw it there.
Is anyone else super pumped? Because I'm super pumped. Okay. So we actually have 2 pins per motor, so that's something that's a little different.
So this is controlled by,
2 pins per motor.
these 2 are controlled by 12 and
What I would like to be able to do is describe it in terms of direction and in terms of power. I would think, or just give it a negative number. It just knows to do that.
okay, so this one is.
Let's just try one of them.
This one is, what do we have? 32 and 34, 32 and 33.
Yeah. Let me. Is that a multi-line comment? No, I think this is multi-line comment. Yeah, there we go.
Okay, so what I would suggest you do is do the exact same thing. Like, don't even change the code. This will test it. So, so 12 is the forward for this wheel and this wheel. 30.
You wanna show it over there?
Yeah. Okay, come with me. So I am explaining it to you as well, just to make sure we're on the same page.
Yeah.
So what we've built is pin. So too much garbage. So we got pins 12, 35 correspond to
12, 33, 34, 35.
12, 35.
Oh, is that how you did it?
Yeah.
Cool.
12, 35 is front left and rear right.
Yep.
And then 32, 33 are front right and rear left. So this means that if we set 32 to 0 and 12 to 0 and 33 to 1 and 35 to 1, it should go in reverse. Does that make sense? So you're going to set these guys, just set them equal to 0 at the start of your script, and then run the exact same script outside of that, but with these numbers. And it'll test it in reverse. Does that make sense?
Can you just give me those pin pairs again?
Yeah.
12 and 35, and then
32 and
32 and
33.
Okay. Okay. I really want to change so much of this. Okay. I don't want to.
Well, yeah, we're just running through our tests, and then we can.
Yeah, that's. Yeah.
Say,
I concur.
Because we're gonna run into something. To be honest, just trying to make sure we understand how everything works before we start frigging with stuff. I'm pulling a U. You need to understand every little thing.
Good. I hate this. All right,
Because I don't want to troubleshoot the wrong thing.
yeah. I need to get out of Vim. I don't do Vim enough, so this is slow for me.
Yeah, Nano.
That is slower. I need an improvement, not the other way. What do you think of Vim versus Nano? Everyone who's watching.
Specifically you, Nacho Kitty.
Specifically you.
Pacifico.
All right, so we're just going to add some more pins here. We're going to set them up. Oh, look, you know me, it's awesome. I'm implying context, you know, from context. I'm pretty sure awesome was where you were going with that statement, right?
Beat us for life. A flip is coming, I'll tell you. I can feel it.
Vim is the awesome one. I wonder if we could do a flip. Also, how do you rotate? I just realized, if I want that as a body to spin clockwise, what do you expect the motors to do to accomplish that?
I expect. Just a second. Let me think about it for a second.
And audience, what do you think it's gonna have to do? Who don't engineer code for a living? I answered last time. None of us the only used by people with engineering degrees. Boom, roasted.
Oh.
Okay, so what we have here.
I think that this wheel has to go clockwise. This wheel has to go counterclockwise. This wheel has to go counterclockwise. This wheel has to go clockwise. Good rotation. I don't think that's possible. Is that correct configuration?
Yeah.
So you came to too.
Yeah.
Yeah.
Yeah. That's okay. So we have a configuration that is sufficient for translation.
Yeah.
But not rotation.
Yeah.
And I wanted both. But we will get there. We just have to do something to get more PWMs. Okay. Something to think about for next time. But hey, if we can do this, we can do whatever the heck we want.
Yeah.
Also, all of the math that we have for here is all translation, not rotation. So it's not like anyone else has solved that we've seen.
Okay.
Right. So that's it's new for two reasons: hardware and the software. We don't really know how to do it. Okay, let me think. So you want 35 and 33 to be the ones that we drive.
Yeah.
And 12 and 32 to be 0.
That's correct. And then it should go in reverse. All four should go in reverse.
Okay, so pins 3 and 4, I'm just calling them that. They're initialized here and they're starting at 0. They do nothing. Yeah, okay. Do I need to provide a duty cycle, or can I just say the start? I'm assuming start is sufficient. I guess we'll find out. I think this is it. We got three. All right, can I run it? You gotta hold it so it doesn't explode.
Okay, so that worked. Cool.
Boom, first try. Okay. Want to do the angle stuff?
Well, kind of in a pickle right now.
We can do that. The angle stuff and all the translation stuff will work. It's just the rotation stuff.
Okay.
Yeah, because we can't control them all four individually.
That's right. Yeah. Which I'm very disappointed by. That's a poor engineering choice on my part.
So we'll figure it out. It's all of us. I'm surprised because we have so many pins on there, but we specifically need PWM.
You should Google. Let's Google. Let's see how to get additional PWM pins on a pie.
But maybe, yeah, I don't know. I don't know how that works. That we need to activate them all, but Yeah, it's interesting. It is interesting. So right now we have a piece of code. It's pretty nifty. It drives the motors forward, and we can make them go backwards. Yeah, let's do something else. I'd like to get VS Code hooked up over SSH. I hear that's a thing. I would very much like it to work right now.
Supposedly you can make PWM with a Python script.
Beautiful. That's what I expected. Because to me, why not?
Yeah. Fair enough.
Okay, that's good. So that gives us like unlimited then.
Well, I haven't looked at the code.
Yeah.
It's just a Raspberry Pi form.
Okay.
This guy says the latest wiring Pi C library has support for software PWM.
Software PWM. Okay.
I think the Python library is built using C. And
Oh.
117. Do you want 17 PWM channels on the Pi?
A little bit. Why not? Oh, sorry, I'm not showing the code. Did I just like do all the code without even showing it? Gosh darn it. I will show you all in a moment. So this is going to be our car project. I'm going to creatively name it car. I'll put RC car. I'm going to have to clean this up later, but okay. Sorry, I'm just trying to figure out where my window just went. I want to install an SSH extension. So this is so we can remote into. Oh no, it's worse than that because I actually have to remote in.
Your
I'm
email is showing on the screen. Okay. Is that email? Or what is that page? Is that email?
I don't know. I don't see where you see it.
It's gone. Yeah, but what is this page? What are you looking at?
I'm just looking for.
Oh, that's just. I saw on the left that you had. It looks like Outlook.
It looks like Outlook.
Just
Oh
from
gosh,
distance.
man. Oh my god, I appreciate the thought. All right, this might not give me what I want because the problem is I need to be able to run inside of Balena. So I'm in a Docker container inside an SSH. So this might not really do what I want. It's upsetting, but we'll try it. Okay.
So what are we trying to do right now? You're trying to get a translation.
Yeah, I just need to connect to it in a different way because I'm coding too slowly. Connect window to host, add new SSH hosts. This is open.
Nacho, what do you think of our new setup for watching the electronics? Is it a little bit easier to watch? I know things got confusing because of the amount of wires that we have, but was it more clear to watch the wiring? Or what about you, Beatus? Do you have any opinions on that as well? Sweet.
Yeah, it's gonna take me just another maybe 2 minutes to figure this guy out. So what I want to do is SSH in and then immediately execute a command. So I think I'm able to do that if I chain two things together. So I have this and I have this command. I don't know if I'd put quotes around it. Maybe I have to do this. This will work. So,
Do you have any questions, Nacho Kitty, about what we've done so far? Or is the car pretty straightforward? What about the driving, the wheels turning, or anything like that? Is that all reasonably straightforward? What about you? You as well, Beatus for life.
oh, beautiful. Okay. Hopefully this will work.
PWM makes the wheels go round. Yeah, that's fair. I suppose that's all you really need to say. What are you guys up to? Are you playing video games?
All right, I'm gonna give up on that for a little bit. I will figure it out later. I just want to be able to code a little faster. Okay, so let's get back to this. Apologies for the delay. Okay, so we have this script, all motors, which we know we can go forward and backwards. So I think we can make this a lot more interesting. Do we want to now try the one with the sine curve? So this would be like move in direction. So a couple of things here that I'm not particularly familiar with is Python and sine.
Help us, Python.
So Python. So there's a math library that has a sine function, and it looks like what we need from the code that was written here, we are getting oh, that's interesting. Plus equals. Interesting. Okay, so we have selected value, which we deduced earlier was essentially the angle. We can actually take a look at the article that they wrote.
Were they using a controller?
Well, here I don't know about that. They were just using this. I don't know.
If you press G, they kind of want you to control
this.
Yeah.
So that selected value, I think, is like this, right? So the wheel angle is the value we want to change. Pi divided by 2, for example, is forward. We got backwards over here. We got left. right at 0. So this should be everything we need. So we need wheel angle in units of essentially what would be I think 2 pi. Yeah, 7 pi over 4. Yeah, so the next would be 8 pi over 4. So it's 2 pi.
Yeah, pi over 1. In the middle there, pi over 1.
Pi over 1. Yeah, I was like, wait, what? Okay. So 0 to 2 pi. That makes good sense. So it's a circle. And our calculation here is, so it says here y is equal to sine x minus 1/4 pi. So if we look at here, so wheel angle minus 1/4 pi.
So wheel angle is x.
Yeah.
Okay. Cool.
So this is actually it. This is all we really need. This is the right file that I want. So I want to create a function, which I also don't know how to do in Python. All right, we're learning everything about Python, and feel free, Nacho Kitty or anyone else, missing important things. Oh, Outer Worlds. I hope you're streaming because I'd love to see it. So we're going to define a function. Given a couple things, I'm going to split screen this because this is going to...
Oh, she showed you how to do it. Def function.
Perfect, thank you. I'm going to do a couple things. Oh, no, I don't want to do that because you can't see my bottom. There you go. All right, I think you can see all the code now. Okay, so...
Why is this such low resolution?
I don't know what to tell you.
She's giving you a bunch of examples.
Perfect. All right, tabbing for the win. Okay, so we're gonna do move in direction. I need to do this a little bit nicer using functions. Correct me if I'm wrong, but we can define the function anywhere, and it will be able to call it. I'm gonna do it assuming that's the case. So, guess we'll find out.
I'm gonna go get us a juice. Can I get us a juice?
Absolutely.
Is there juice? No. What is that?
You can there's definitely juice downstairs. If you go down there and say just
and say
juice appear and one of my some virtual assistant will help.
Oh. What do you want here?
There's a special juice that's what it's actually just water.
A special juice.
Yeah.
Okay. I'll go get your special juice.
Yeah. It's I need to be hydrated more. All right, coding time. You don't want to see all the coding? It's gonna be great. We're learning what a function is.
I do want to see it, but I want juice.
So needy. All right. So first off, we want to say here's a wheel. It has 2 pins that are used to determine its direction and magnitude, like the speed. And we also want to pick a wheel direction. So fluctuation has to come before when it's called in the script. I don't understand. I'm so used to JavaScript with hoisting. Well, that's very upsetting, Nacho Kitty. I'm upset. Oh, before it's called. So if I define here some func, and you said it looks like this, so print do the thing, and then I define. Oh, don't need a semicolon. Main, and the main is here, for example, and then I call main below. Technically, in the execution path, it is defined above. So is that valid? Very literally, it's called. Okay. That is valid. All right, thank you very much. Okay, so a couple things. We have motor pins and other setup. I would very much like to move all of this into something else. So I'm going to define some setup. Did I just delete it? Or there we go. Okay. Gosh, it's been a while since I've used Fan. All right, this code here, duty cycle something. Okay, so this is going to be this is another one. We'll make this just test or something like that for now. Well, that's upsetting. I really miss not using Vim. Vim is fine. Vim is very good. It's just not what I want to move quickly right now. Okay. Indent. Copy this. Paste this. Indent it a little bit. Actually, I could have just defined it above, so that was not. All right, so we're gonna go backwards. I should probably talk more than this, but just trying to navigate is challenging enough right now. Go backwards. So what I want to do is just get us in a point where things are a little bit nicer structured, because we're gonna have to deal with a lot of pins, a lot of motors, a lot of variables, and I want to make sure we have common blocks that are reusable, make it really clear for us to develop. So we got our functions here. We have our setup that I need to call go backwards. Now I do wonder, are variables global? Actually, I'll ask, not your kitty. Are variables global by default? I guess I'm just gonna find out and see if this executes. Nope. Get back. Globals are weird. Good answer. Go backwards. I don't usually like global variables, but in this case, I might make an exception. And I think I just might. So this setup stuff, I'm actually going to just move it back out. I just don't want to deal with it right now. So that solves that problem. Whoa. Okay, we got movement. So what we've done, we just restructured it just a little bit. It's not much of an improvement. Just getting the ball rolling. Learning a little Python as we go. So we have this go backwards code. We're not going to use it. It's just there as a reminder. What we actually want is to be able to you can declare a global var. Okay, cool, and then modify it. Reading still find without, as long as you don't create a duplicate variable name in the scope. Okay, cool. So it has some kind of scoping, and it takes priority with the locally defined variable. Okay. So we have this JavaScript code. We want to write the equivalent into Python. How do we want to do this? So if we said wheel angle, what do we want to return? We would want to return essentially two numbers, right? We're essentially, for any motor, we want to tell it if it's going forward or backwards. And so this this sign value, I think it actually will give us negative numbers. So, so if that's the case, like you see in this chart here, we're going to give it this wheel angle value, which in this case is called the selected value. It will actually return us a value for the blue wheel and a value for the red wheel, or the pair of wheels, I should say. One of them is going to be negative, one of them is going to be positive, so they're offset on the sine curve. And yeah, so let's just do that. So, thanks very much.
Well,
Appreciate you. Did you get a good juice?
I drank some.
Yeah.
Drank some.
Oh,
Downstairs.
you drank it downstairs? Oh, wow.
Okay.
Didn't last for long. So, so let's just say we move wheel angle. And that's it. That's all we're going to do. We have some Python JavaScript code we're going to convert to Python. That's this. I think that library that we found earlier, and Natriki was just helping me figure out how to code all of this. So this here is a math library that we need. So let's go all the way to the top. What's that? All good? Yeah, that's a good point, actually. Probably not something I can solve in the immediate time. Let me just, 1 second. It's probably not a big issue. 1 second, I'm just gonna fix something up. So our objective right now is converting the JavaScript code that we know visualizes well to real code that's yeah, actually gonna have. Let's see. Okay, 1 sec. I can't get over to this desktop. Continue this section as well. Okay. So we've imported the math library for Python. We are calling the sine function. We're going to use this wheel angle value. Now we need to get something, it's math.py, so that's different here. And again, math.py. So this is all translating the JavaScript code to Python code. And in our case, we don't want to use selected value because we looked at the code and reasoned that this is actually the wheel angle, and that's a more interpretable name. It's more informative. So it's when you're coding, you're always trying to make something that's informative for your readers. So we have wheel 1 movement, wheel 2 movement. Given a wheel angle, we're going to calculate those particular movements, and boom, and that's it. So I think the other thing, let's see. So move with angle. Move with speed and direction. So that's the other thing, is how do we want to communicate? So I think in this case, our forward is going to be 1 and our backwards -1, and then we'll have to translate that to what the PWM expects. And that's fine. That's going to be pretty straightforward to do, but we'll create a separate function to do this. So move with speed, and these names are not the best, but it's just something that's simple for now. Move with speed, and we'll use speed. And I'll just make a little note here. I think that's how you do a Python comment. Nice view. Oh, is that Lucas walking in? Yeah. Not strictly approved. So 1 equals forward equals backward. And actually you have your diagram there. You said it was, if it's forward, it's going to be 1, 0. If it's backward, it's going to be 0, 1.
Yeah.
Okay, so that's good. So we'll hold that off for later. This right here is going to be useful for that. Motor speed, wheel angle. Okay, so I think this is good. So we can say move this motor with the speed, and we'll have a function that can handle that. But I first want to print out and make sure that our math is working as expected. So move with angle. Let's print these values. I think earlier we had something. Python print format. So we want to print out our input angle and then the respective output, and then confirm that our expectations. So right here, okay, here's a good example. So you print and you use these percent symbols. So you have percent %d, for example, as digit, and percent %s is a string being a piece of text. So this right here is actually what we want. This one. This is the nicely formatted way of doing it. We'll just mess up my terminal, apparently. Okay. So we're going to print. We're going to print. Oh, I see there's two different ways of doing it. Using format. Okay, I'll use format because that might be a little clearer to use. So we want to print at angle, and then we'll say here's the angle, motor 1, speed is, and motor 2 is free. Format is always what I use. Would it be a similar format to this though? Because I see there's two ways of doing it. But yeah, there's this symbol here, which is I guess a different way of doing format, or this one. I'm going to use the second approach. I feel like this is cleaner. So we're format, and we're going to pass in these values. So the first one is wheel angle. The second one is wheel 1 movement. Actually, I'm going to rename this because we're not describing it as movement. Our verbiage that we're using is speed, which maybe is not the best because we have negative speed. I think people can intuitively figure out what that means though.
Velocity.
Velocity. Boom. Except I always feel like there should be a nice unit there, but I could put velocity. You want velocity?
I don't care. You're saying that your problem with speed was there's no direction. Velocity has a direction.
Yeah. No, it does definitely solve the issue I have and creates like 5 more. All right, good. So we can call this function, give it a wheel angle from 0 to 2 pi, and it will print out this message saying with the angle, motor should do this, motors 2 should do this. And all right, so I think that's pretty much it. Let us test it. So there's a couple expectations we have, and we can use this to test our value. So we have this here. Move at 0. Move at. What were the other points that we noticed were of interest? So if you're at 0 here, if you're at 0, the motors are going. I don't think they're going full. So that actually here they're stopped. That's interesting.
Stopped in full.
Stopped in full. So I wonder if 1/4 pi is actually a good thing to test, because it's very obvious if it's a good value. Yeah. So let's just test these. So this one's good. So math.pi divided by 4. So we'll make a note. Expect forward and 0. And then let's find another point that we have an expectation for.
The opposite points, probably.
Yeah, so like we could do this. I think this one, they're the same.
5 pi over 4? Oh.
Yeah, I want to test this one as well. So math pi divided by 2, we're expecting them to be the same value. Limit to precision if desired. Actually, that's a good idea. I'm curious what it's going to print out. I suspect we will limit the precision. That's a really good idea. Let's do it wrong first, and then we'll do your way. This is 3 pi 4. Sorry, I'm seeming like I'm dying here. Too much talking today, you know. Move with angle. So math pi, and this is 3 times pi to about 4. Expect. So in this case, we expect one of them to be going forward, one of them to be still forward, and 0 again. We don't really know which at the current time. We probably look at it, but let's just take a look once the code prints it out, and then we'll do the same here. This is everything in reverse. This is 3 pi half. Cool. All right, what do you think, Lucas?
Let's give it a round.
3 pi
So
half.
the last one should be all reverse, right? I'll keep an eye and see if everything goes all forward, and I'll just flip everything. But it should be the right direction.
This one currently does not actually run anything. We're just testing the values.
Oh,
And that's why we made some notes about what our expectations were. All right, so let's run this. Top out of range. I feel like we did something wrong. 0, 1, 2. This went off complete. 0, 0, 2, 3. It should be 0, 1, 2. I was curious if Nacho Kitty caught that. I'm just gonna put bugs all over the code and see if Nacho Kitty or anyone else catches it. Let's run. So, our first one, given an angle 0, motor 1 is speed is this value, and this over here is the negative of the same value. So if we go 0, what do we see here? Yeah, and they look pretty similar speed. One's the opposite.
yeah, one of them should be less.
Should they be less?
Well, looks like the. Yeah, okay, fair enough. Similar. Yep.
Yeah.
Similar.
So that looks good. At speed, at angle. Oh well, that's a problem. we don't describe it in a way that is useful to read.
It's still.
Well, this value we know it because it's the list. This value here, it is 0 and 2. So that makes sense. 0 and 2. At this angle here, I think that was...
I see your angle, yeah.
Yeah, this one here, I think that was 1 is going forward. The 0. What was this one? So where our tests were. Let me just break it down here. We don't have to do this the hard way. We can just read it. It is unfortunate. It's a little bit poorly written. I apologize for that. So. So we got here. Good luck, folks. I'm taking off. Thanks, Beatus.
See you, Beatus. Have a good night. Thanks for stopping in. Appreciate it.
All right. So we got here.
Have a good day at work.
Yeah.
Well.
Okay. So we're expecting forward and 0. So we got forward and 0. Great. We expect same value for all motors. Yes, we received that. We expected 0 and forward. Yeah, we got forward for this motor, and this one is approximately 0.
That's a 0 guess.
Yeah, I don't think it can represent it well. So that's okay. And this one, expect the same for all motors. Yes, good. So our code appears to be working as we expect. Now,
if you limited that one, if you limited the sig figs, it'll probably get rid of that 2 to the negative 16.
We should crop it.
Yeah.
That's a good idea. Okay.
Hit
it.
And run those motors and see. We can't actually test it though. I'd love to put it on the floor, but we can't.
Because the because of just the Ethernet, right?
Ethernet's long enough. We could put it on the floor
Ethernet's
for a bit.
huge. Yeah. The only problem is I don't know. We have to tweak back the speed. Make sure it doesn't drive off on us.
Yank out the cord. It'll be fine. I'll catch it. I'm fast.
We'll see how fast. That's for sure. All right. Next function we want to add. So yeah. So right now it doesn't really do that much. We need it to move given a speed and given a motor. So what I want to do. Yeah, the prompt, it's just a lot of stuff. I want to do like classes and things. So we have to call these things. We have to call the change duty cycle and set these values. So let's go here. I keep pasting in the wrong spot. Okay. So let's say we have a motor, and a motor is comprised of two things. It has essentially the two pins. So a motor has one, and a motor is two. So let's say we have motor 0. So we get the first of the two pins. And so we gotta figure out if our value, if our speed is greater than or equal to 0. Oh, that is not Python. Is that Python? Else. So if our speed is greater than or equal to 0, so then we know that's going forward, and forward, therefore, all of the magnitude is going to go on the first pin, and the other one should be zeroed out. So actually, let me change how we're doing this a little bit. Sorry, I'm actively changing things as I go along. So let's say we have motor 1, and it's comprised of two things. It has the first pin, because we described it as we have two pins that we have to communicate over to control the motors. Mm-hmm. And these are going to be so 12 and 35 are the pair, and 32 and 33 are the other pair. So if we have our motors here, we set up these pins, set up the controls. Let's put it into, so motor 1 is equal to 12 and 35. So 12 is pin 3, goes to here. So that's PWM 3. So pi PWM 3. So that's the first pin that we want, and the other one is 35, which is this value, and so that's PWM 1 is what that variable is called. I might rename those later, but just for now, let's just do this. Okay, so we have motor 2, pi PWM, and this again, let's go out, just double check. So 32 is 4, 4. Yeah, and this part's a little bit messy. I need to go back at a later time and clean it up, but it's good enough for now. So essentially, we have two variables now that represents these motors. Create reusable variables for motors, and this is going to be handy later, because we can just pass these down and say, hey, here's your motor, use these.
I'm assuming, I'm just behind, I think.
So
Actually,
you're gonna your PW where you go up to the top, where your PWM shouldn't be _2. It's gonna cause some issues.
Yeah. Appreciate it. All right. All right. Sounds good. Thanks, Nacho Kitty.
Thanks, Nacho
We're
Kitty.
probably wrapping it up soon, anyways.
Yeah.
Love to see a little progress. Thanks very much. Yeah, we're getting close. We're almost having it driving. Maybe by next time. So we got, in this case, if speed is greater than 0, we want to go forward. If we want to go forward, we want the first pin of the pairs, so motor 1. We want to change duty cycle and pass in speed. And then the other one, change duty cycle and pass in 0.
Thanks, Nacho. Have a good night.
Have a good night.
See you soon.
Thank you. All right. Now, if it's less, want to have positive speed. How do you do absolute value? I would assume. I just want to double check. Is it like math at ABS, for example, or is it a built-in function? It's built in. Okay. So now we know the opposite. So the first pin is going to be always 0, and the second pin is going to be our velocity or speed, and it's going to be positive. And that's it. So this function here, give it a motor. It has 2 pins. The first pin and the second pin, marked as 0 and 1. We know that we have to take the speed, and like we talked about earlier, if we want to go forward, we use the leftmost pin, so this one here, and we give it and make sure that the other pin is 0. And yeah, that works. Is that pretty much what we described?
I think so. So its speed is great. So I don't think I quite understand the its speed is greater than 0. Its speed.
So that's just a way that I can make sure. Actually, how about this? This is easier. Is backward less than 0, or actually no, it's should be the other way around. Forward. So if it's forward, if it's forward, then I want to do this combination we've already described above. And if it's backwards, do it down here. And the key thing is, if I'm going backward, I have speed. It's a negative value, and I know that. So I can't use negative value. I need to convert it to positive and then use that positive value.
Yep, 100%.
Good. So we have this. So when we're moving, this moving part right here, it actually moves 4 different motors. So we're going to use move with speed, and we're going to go back to that code down here, and we had 4 wheels. We had this one, here, here, and here. This movement 2 was actually negative, and this one here is positive. So we have 4 motors that we're going to do. We'll do motor. Wait, we have 4 motors. I didn't set up enough above.
Well, we only have 2 motor controls, though.
Oh, we don't need. Oh, yeah, sorry. Yeah, so we actually only need to make sure. So at a hardware level, we've already mapped this one and this one, and this one and this one. So we only actually have 2 motors. So we have motor 1, and we're going to provide the wheel 1 speed, and we have motor 2, and we're going to provide that, the wheel 2 speed, because the hardware itself is already separated out that these are the pair, and these negative ones are the pair. And I think wheel 2 speed should be negative. I guess we will test that out and find out soon. Okay. This actually should drive. So let's make sure it is delayed. So sleep is the delay function. It's measured in seconds, so you can see how there's a decimal. So let's have it sleep in between each of these. So sleep, and we'll do each of them for 3 seconds. How about that?
So first is forward and 0. You should have it when we're testing. You should tell when it goes to sleep each time. Tell me what I should be seeing.
Yeah. Yeah. Let me just check. So I will note this now. So if we are at 0, it should be going full right. Right. If we are here, so this is pi divided by 4. This is 45 degrees right. I'll just put front left. Front left should be going forward, and the others, yeah. Front left forward, and then front right is off. This one here is pi divided by 2, so that's all forward. This is 3 pi 4, so this is the front left is off, and the front. Can you make it? Front left off, front right forward to align with this, and the last one here is 3 pi divided by 2, which is all reverse. Okay. I hope this doesn't explode.
No word. I believe you. I don't believe you. So I have a feeling they didn't leave it to do the thing long enough.
Oh, it needs to be normalized. The values are greater than 1. We can only give it 1, right?
That's correct.
So the duty cycle actually goes from 0 to 100. So I want
duty cycle. Yeah. You're still, if your duty cycle is from 0 to 1.4, yeah, you got to normalize it to 100.
Yeah. So I got to normalize to 100. Okay.
Yeah. Yeah. So you're still below the threshold. The threshold's
I think
like 2.
Yeah, I think the max is actually. I think the max is actually 2. I don't know what they did to normalize these. So like at this point here, it's going its fastest. So my goal would be whatever this is, that's 100. So whatever. Let's just do the math here. Now this will be a Python. Math sine. So we have math. Is it pi all caps? Yes. Pi divided by 4. And minus 1/4 of pi. So I want to be past that. So that's 1. That's definitely not the highest then.
Why would it's a unit circle?
Yeah, that makes sense. Why do I get
What's
1.4?
the 1.4? Yeah.
What is 1.4?
Which calculation? Because it's not the pi.
He times it by 2.
That's his normalization.
Yeah. Why did he do the 2? Yeah, he did. That's.
So you can just multiply by 100. You should be good.
Yeah. I'm just curious why he did by 2. Okay. Well, that's fine. I'll figure that out.
I would say right. This would be the one I would imagine. It's
Let's go to 1. Maximum hypotenuse is 1.4. So we are seeing that.
So it's because he was going with a joystick. Or not?
We effectively are. So the joystick is describing the angle, and we're just doing that by providing it. But too greater than we want to scale down to. Problem is they both have to be scaled down. So we just need to make sure that whatever the maximum number is, yeah, we can do that. So whatever the max is for the two of them, we say that is the highest value, and then we divide by it. We divide them both by that value. So get maximum of both, and then divide them both by that, and then times by 100.
What do you mean the max?
So like if we have 0 and 1.4 being the max,
yeah.
then we say what's the maximum between the two numbers, 1.4,
yeah.
And then we say all right, divide them both by 1.4. So now we're 0 and 1, and then we times them both by 100. So it's normalized to the maximum value, and then scaled up to 100.
So then it's not linear scaling.
Yeah, it's trying to use. It's trying to always go to that angle, but at the max speed the motors can do. Yeah.
Okay. And the only time that's going to be an issue is 0, but 0, you just want it to be 0, and everything else since max speed isn't going to affect it. Okay, yeah, that makes sense. I'm gonna do it.
We're gonna have to change it later, but I think that's a good start to normalize it. Let me think of this for a second. So I need to normalize.
You have to normalize everything to your max number.
Yeah.
Which would be 1.4. So divide everything by 1.4.
Yes, correct. Yeah.
Not just specific instances.
Yeah, always. Now, what does that mean if I give it 0 and negative 1.4?
You got to take your absolute.
So I get an absolute them both.
Yeah.
Okay, that's fine.
Or no, you don't have to. You can just say magnitude. You can use a magnitude function, and then you don't have to change the sign.
There's a magnitude function.
I think so. That's a normalized function.
Yeah, we don't care about the sum. So this is what I was going to do: is iterate over all, and then divide, but by the max.
I thought there was a magnitude function, so you could get the positive and not have to change the sign.
I think there is, but there are other things referenced using like NumPy and other libraries.
Fair enough.
Okay, no, that's okay though. So let's see, normal coefficient is can be the max of two numbers given the absolute. The only problem is going to be if so it actually will get faster if let's say they're both for some reason 0.5, it would again make them 1. So that's okay.
No, so that's why I'm saying you always got to divide by the 1.4, not the maximum of any two numbers. So you're normalizing to the max, which is 1.4. So like if your value is 0.5, divide 0.5 by 1.4.
Consistently.
So that 0.5 doesn't become 1. 0.5 actually becomes quite a bit smaller than 1.
Okay. So the only disadvantage of there is we're not we could move in that direction faster if we scaled it up to 1 or 100. But right, so
Well, I guess what do we want? Do we want variance? Do we want the ability to
yeah. So like if
select
we
the speeds, or do we want
if we-
just fast as possible?
well, so if we do what I'm saying, where we normalize it to 1 and then we scale it, we multiply by 100,
Mhm.
is we can just pick whatever 100 is. So then we say, given direction, you now have that like unit circle, and we normalize it to 1
Mhm.
for all the magnitudes,
Yeah.
and then we can pick the 100 value. So we can say, I want to go in that direction. Here's all the angles, and then also stretch them by 100, stretch them by 1. Like we can then pick angle and speed.
Yeah, right. I understand. I understand that, but I don't understand. 0.5 doesn't need to be 1. 0.5 ends up being like a duty cycle of like 30. Right? Because like 0.5.
At a 1.4, you mean?
Yeah. I don't know the math, but
Yeah, that's fine. Yeah, if you're close, that's pretty close. I mean,
yeah. So it ends up being 35 duty cycle, which is slow, but then just jack it up.
But that's what I'm saying is my way. I can guarantee I can jack it up to 100.
I don't understand what you're.
So
I
like
don't
we
understand
can,
why 0.5 becomes a 1.
so let's say we got this number.
Yeah.
How much do you jack it up by?
Multiply by 100.
Right. So so you want to consistently divide by 1.4.
Yep.
So we multiply this by 100. Okay. But it's still not.
Now on PWM, that's your 35% PWM.
Percent. So it's not like let's say 0.5. Like 1 was 0 and 1 was 0.5.
Mhm.
There's definitely more that we could give it.
I see what you mean. Okay.
So that's why I'm saying pick the highest one, normalize to 1, and then we could pick the times by 100. The 100 is the speed, like the magnitude, like the velocity or whatever, in any direction, and then all we have is like normalize x and y coordinates and just scale them up by the 100. But we at least normalize them to 1, given what the highest value is.
Yeah, well, I mean that's what you did there. That's normalized.
No, that's not.
That is normalized. It's divided by the highest value that we have.
Highest value possible.
Yeah.
Right. But I'm saying I don't want the highest value possible because it's only getting 35%. I want to see 100%. Why? Because if the other value, if it's 0.5, and I don't know, like there's tons of combinations, right? But if it's 0.5, I want it to be 100 on the full one and 0 on the other, not 35%, because it can open it up. There's no constraint.
Mm-hmm. I see what you mean now.
And our camera's freaked up again.
I see what you mean.
All right, we're just gonna go for a very short break.